I just uh, I just recorded a 2 hour plus video on two news items. One about a gamma ray burst event with the following name, and another news item about two Neptunian type worlds, as in ice worlds, um, colliding with each other. Unfortunately, when I was recording that video, the portion of my notes, my scribbly notes on this app did not record because I only chose to record the the Chrome version of the segment. So I don't know if that video is going to make a lot of sense when I'm drawing and trying to talk about particular areas, trying to meditate on the associated topics, and as they were emerging in my mind from my non physics and non scientific perspective. That being said, let me do a very short recap of what I was referring to by this time highlighting the notes that I had taken. So, just to recap, first of all, what I'm saying is conjecture as best because I don't have a background in physics. Uh, Secondly, the two news items that are being shared. The first one is about an observed event that occurred in a galaxy, well, in the range of a galaxy, because the two stars in this news item that you see in front of you were in a galaxy far away, 900 million light years away to be precise. I think that number is here somewhere. Okay, well, the number is not here, but if you Google uh, how far away is this gamma ray burst phenomena, how far away, then you get the number, and the number is 900 million light years away. It is very, very far. Okay, to state the obvious, it is not in the Milky Way. Here we go. Distance 900 light years. I don't know what co-moving means, but this is the second brightest GRB ever observed. GRB, once again, stands for gamma ray burst. So, this event, which I was talking about, this is the video. Here's the link. In detail, I was speaking about this event and the other event also. I'm going to talk about the other event in a second. But again, this is in a different galaxy, far away, or was in that galaxy and got kicked out. These events of the water worlds, two planets collide with each other, Neptunian type planets, icy planets, is in the Milky Way. It's approximately 1800 light years away from us. 1800. So, first, you've got something that's massively far. I mean, it depends how you look at this. 1800 light years away is still massively far from the solar system. I mean, it's a relative scale of things, but compared to the galaxy, is not that far. Now, I don't say this in a conspiratorial sense or doomsday sense. I just only have more questions. So I started talking about a bunch of different things, but once I started drawing backgrounds, I guess I was looking at the second article first. And considering the fact, the first image here represents the structure, the scale of the Milky Way, not the galaxy in the first article, the Milky Way. If the Milky Way is 120 light years across, then roughly speaking, we're looking at a radius of 60 light years from the Sagittarius A star, plus minus. And so if you divide this region, uh, where is the pointer? So does this work? Yeah. So that Sagittarius A star, let's assume the solar system is somewhere here. The dot is not to scale. Okay. This is solar system, like a tiny, very tiny green dot somewhere. And this whole circle or square that's being created around the solar system represents an area that's typically 3% of this total space, right? So if this represents 100%, that would be 50%. Actually, I was saying this one quadrant represents 100%. So that would be 50%, and that would be 25%, and that would be 12%, and that would be, well, 12.5%, and that would be uh, well, 6.25%. If I did the math right. It's late in the evening here. And somewhere in this range is like, this is like not to scale, but just a very crude assessment that relative to Earth, that event happened relatively close by, 1800 light years across. Okay, obviously that may not have any bearing for humans, may or may not for a long time, but it's still interesting to speculate. If anything, makes you want to have more data about the structure of the galaxy. Then I started thinking about the different. Oh, sorry, I missed a page here. I started thinking about Sagittarius A star, which is the supermassive black hole in the middle of the Milky Way, and there was another galaxy called the Sagittarius dwarf galaxy, not Sagittarius A star. That is the Milky Way at the center of the. Sorry, that is the supermassive black hole at the center of the Milky Way. Sagittarius A star is a spiraling. Sorry, it's a dwarf galaxy, much less smaller than the Milky Way, which is 100 billion star systems. Okay, and this was something I spent a fair bit of time on. And if it makes sense, you can watch the first video or watch this video and then watch the detailed video. Um, but I was looking at the kinds of uh, black holes. So you've got different kinds of black holes. You've got the stellar mass black holes, which is approximately 99.9% of all the black holes in the Milky Way. These are 5 to 20 stellar mass. That's how much um, pull they hold. Is the equivalent of the pull that five of the stars that the sun, five suns that we have, that's how much pull it would hold. Then next is the intermediate mass black holes, which they amount to roughly 0.01%. And I kind of took a rough estimate, uh, considering that there are 100 million to 5 billion black holes in the Milky Way. I took a higher estimate, higher end estimate, and amounted that to 500,000 intermediate mass black holes. These black holes hold 1,000 to tens of thousands, so I just kind of put it as 25,000 stellar masses or solar masses. That means, again, one intermediate mass black hole would be the equivalent of 1,000 stars placed inside of it. That's how much pull this black hole would exhibit. Then there's the supermassive black hole, and so far the evidence suggests that there's only one in the Milky Way. It has the equivalent of 4.3 million solar or stellar masses. There's the reason why stuff just doesn't fall in the black hole, because you've got 100 billion stars across the galaxy and other phenomena, and then you've got a supermassive black hole in the middle, which is called Sagittarius A star, which has a gravitational pull equivalent to 4.3 million stellar masses. I was talking about a bunch of different things. I was also talking about the planes of the galaxy and these different spirals. I think there are four major spirals, uh, but they kind of form something called the galactic disk or the plane. And these different planes are relative to each other on a 10 to 30 degree angle. And there's no plane that goes perpendicular to the galactic plane, at least according to ChatGPT. Now, when you Google images of Sagittarius dwarf galaxy merging with Milky Way, then it looks like it's coming at an angle whereby the 2D representation of a 4D reality, three dimensions of space and then time, it looks like they're trying to show it that this is coming at a somewhat perpendicular angle. Well, relative to the motion of the plane or the spirals within the plane, the question is what's happening there, and then the question is what's happening with the Sagittarius dwarf galaxy. Because if you've got spirally arms, I'm going to draw on top of this, but if you've got spirally, let's do this again. If you've got spirally arms like this, right? It's actually really like this. Well, it's relative. You got one or two, whatever, how many, four arms. It doesn't really look like this, but you get the point. And this is relative to us. This is parallel to us, right? This is parallel. But then you've got a dwarf galaxy coming in, and it's not parallel to us. It's relative to the galaxy and also to us. It's coming at this angle. So it's not exactly 90 degree perpendicular, but it's not 10 to 20 degrees of an angle either. It's somewhere between this range, right? 45 to 90 degree. It's not 90 degree, but it's somewhere. I don't know how this dwarf galaxy is coming in. And it's got these spirally motions also. It's not as big as the supermassive black hole, sorry, the Milky Way itself, but it is interacting with the. So I had questions like that, and the unfortunately this open board was not recording at the time, but these are the question I posed, that what is the general motion of not just the planets within the Milky Way and the Sagittarius dwarf galaxy, but how are the black holes moving within this range? And I built on top of that thought experiment to say that space is being worked in three dimensions plus time. So if you've now got Sagittarius A star here, and you've got stellar masses black holes here, obviously this is not to scale because this is 4.3 million stellar masses, and this one is anywhere from 5 to 20 stellar masses, right? Whereas the intermediate mass black holes are in the range of, let me pull it from memory. 1 to 25,000 stellar masses or more. Could be 40, 50, 60, 80,000 stellar masses, but it's not 120. So there could be some black holes in that range, but I don't know if any have been detected so far or suspected. So it asks you questions like, how are these black holes moving? Are they also moving in a, if this was the general direction of the planets, as that arrow represents, that was this also the movement of these black holes? Or were they coming like as part of the spirals in the Milky Way, and also there could be other sized black holes in the, the spirally arms of the Sagittarius dwarf galaxy, which is going to merge once again with the Milky Way in about 10 million years. But I was thinking maybe there are some other bands which may or may not have black holes. And because the main question I had going back to the two articles was, why did this happen in the galaxy 900 million light years old? Was there something equivalent of black holes of a certain size or range that these two stars came in contact with? Or maybe the supermassive black hole in the middle of this galaxy, and thus resulting in the ejection of these two stars. And specific to the Neptunian kind of worlds colliding with each other, well, different obviously scenario, but what was the reason for this to happen? So I was kind of looking at this from that perspective, and kind of got into a fair bit of detail, unfortunately, once again. And to close off, I was doing the same, and now asking the questions with regards to what is the relative motion of the black hole now itself, not Sagittarius A star, but the stellar mass black holes and the intermediate mass black holes. What is the general motion? What is kind of built up on in the previous one? I was talking about the warping of the space time and the potential stellar masses coming in contact with the black hole, as the planets within these around these stellar masses, as the suns. Because if you've got one stellar mass, uh, like here, as the size of the sun, then you've got a stellar mass black hole. Sorry, a stellar mass black hole exhibiting stellar masses in the range of 5 to 20 stellar masses. So contingent upon how near or far it is from the stellar mass itself of the planets, because the planets are relatively speaking close to the star system, relative from the perspective of the distances between the star systems and the distances between the star system and a phenomena like a black hole, not Sagittarius A star in this case, at least not in this case, but relative to that star system itself. So I was that's what I was talking about here, but here I was talking about the relative motions of the black holes itself. How is it moving? Moving the same orbit as the um, I'm tired right now. Is it moving in the same orbits as um, the stars themselves, or is there some other trajectories that are involved? Also, what happens when one stellar mass black hole comes in contact with another stellar mass black hole? They do a little bit of a dance of some sort and then eventually end up merging, because we have seen clear evidence of phenomena like that with smaller black holes merging, I think, with Sagittarius A star. Um, but for I don't know for other mergers of black holes in this case, right? Because going back to the first article that's linked, the two stars eventually, after many passing of many millions of years outside of the frame of the galaxy itself, um, did merge. right? Several hundred million years later, they did merge. And once they merged, they formed a black hole in this situation, right? They collided, formed a black hole, and kind of goes from there. I was also talking about, uh, I think I've read this related to, anyway, I won't go into the details, but there's some, I feel there's some data to suggest that stellar mass could be in the in the in the in the gravitational pull of a supermassive black hole like Sagittarius A star. As it is in that flow, it gets whipped up to speeds like 80 or 90% the speed of light. So I was kind of thinking maybe that kind of item is related to why this phenomena was observed in this galaxy that is 900 million light years away, as I've done the Google search again to showcase how far this is. Another different phenomena, possibly different set of reasons, different phenomena. Unfortunately, Open Board did not record in the first instance, so that's why I'm doing this again. And if you'd like the full video without Open Board data, then here's the 2-hour video. And overall, be very interested to learn more about these phenomena and black hole physics itself. If you have any leads, please find me and share this information with me. You can find me on LinkedIn. You search for my name, the channel, which is Adil Khan, and add the word awake. Find me on LinkedIn and please share good information with me. Thank you very much. Have a great day. I apologize that this didn't record the first time around. Thank you very much.